Okay, so I'm looking at sulphur dioxide reacting with oxygen in the presence of a catalyst to produce sulphur trioxide. So I've got this equation here. Plot the values of delta G against T, and then find delta H and delta S, and what temperature does it become feasible. Okay, so this is slightly different because it's just looking at your graph plotting skills. I'm looking here and I can see that I completely negative on the delta G, so having a delta G that starts at 0 and going negative, and I need at least 120. So I would count up the squares on here and decide whether 1 square would be 10 or 1 square would be 20, 1 square would be 5. I've already pre-done this, so I'm going to go with, if I start at this point here, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. Okay, 120. Maybe I'm going to go up the top. I'm going to start at the top here because I think when I extend my line backwards, I'm going to need a little bit more at this point here. So normally I would do this in pencil because that's the way to do it. And then I'm going to do my temperature. I'm going to do my temperature at the top here. Alright, so 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 40, 50, 60. So minus 10, 20, 30, 40, minus 50, 60, 70, 80, 90, minus 100, 100, 1 minus 120, minus 110, 20, minus 130, minus 140, minus 150, minus 160, minus 20, minus 30, minus 40, 50, minus 60, minus 70, minus 80, minus 90, minus 100. Okay, so and if I do the temperature along here, if I do it in 50s, I think 50, 100, 150, 200, 300, 400, 500, 600, 700, 800, 900, 1000. Perfect. Okay, so plotting 400 and 120, so there's 400 and there's 120. Again, I would normally do this in pencil. 600 and minus 82, there's 600 and 82. 845, there's 800, there's 40, so 45 is going to be in the middle there. And 1007, so that would be somewhere about that point there, wouldn't it? Right, let's draw that straight line relationship. Oh dear me, we've gone past. Right, this was my rubbish graph, so let me see if I can extend it and let me see, what's that? That is 2 centimeters. So what does 2 centimeters equal on here? 2 centimeters is 40. So that is 2 centimeters, and that's the equivalent of 40 kilojoules per mole. There's 2 centimeters there. Actually, yep, it's equal to 40 kilojoules per mole. So this must be 160 plus 40 is minus 200. Okay, so I can say that delta H equals minus 200 kilojoules per mole, and the gradient, so minus delta S equals, and we can do, let's see, let's go from here. And we'll do that. So this is 10, 20, 30, 40, 50, 60, 75, so that's 75, and this is 50, 100, 150, 200, 250, 300, 350, 400, that's 400. So it's 75 over 400, which equals 75 divided by 400 equals 0.1875. Just want to make sure you are aware this gradient is positive. That's why this here, this term here, is positive. If this gradient was going in the opposite direction, then it would be negative. Okay, so this gradient would be negative. So minus delta S would equal minus, and then whatever this value was, but this is a positive gradient, so this is positive. Okay, so we can say that delta S equals minus 0.1875 kilojoules per Kelvin mole to the minus 1. Okay, so what temperature does the reaction become feasible? So it is feasible. What temperature does it cross this axis here? It crosses at, when delta G is 0, it crosses at this point, which is just slightly less than 1050, so maybe 1040. So when delta G equals 0, T equals 1040 Kelvin. So the reaction is feasible at temperatures less than or equal to 1040 Kelvin. So I've put when delta G is 0, temperature is 1040 Kelvin, so the reaction is feasible at temperatures less than or equal to 1040 Kelvin.